Hi there, and welcome to our webinar training for this fifth grade STEM storyline titled What's for Lunch? This STEM storyline was created to support the Mixtures and Solutions kit. However, it can be implemented without the materials that are provided in this ESD 112 kit. Thank you so much for joining me today. My name is Pranjali Upadhyay, and I am the Integrated Curriculum Coordinator at ESD 112, so I function out of Southwest Washington. My job is to create curriculum and support programs that are able to help teachers in creating equitable STEM experiences for their students. Some of my work also is supporting STEM in my state of Washington. My intentions today are for you to feel ready and super excited to teach this new fifth grade STEM storyline to your students. And here I've included a link to our slides presentation that I will be using in the webinar. I would advise you to pause the video and to click into your URL browser and to type in this bit.ly link. It will take you to our slideshow on Google. And then you will be able to access all of the links that are embedded within that and be able to click and check things out. So I would recommend you pause and type that bit.ly link into your browser, have that on the side accessible so you can access all our resources. You can actually click this link on the screen right now because this is just a video screencasting my computer. I've also included a link to our STEM materials website where this unit is housed. So if you go ahead and click that link, you will get to the page where you can download the unit and follow along as we go through this webinar. I would also recommend that you open that up on the side, and that way you can look at the actual curricular unit and follow along and take notes for yourself so that you feel ready and able to access all those materials. Some thoughts for you as we start. This is not actually a FOSS training. This is a training for our STEM storyline. So I will be referencing certain places in the unit where our FOSS activities are embedded within. However, I will not be spending time going over the hands-on aspect of the FOSS. I'll include some slides at the end of our video that will give you a quick overview of the FOSS website and how to access some of the online teacher resources there. There are videos and other resources on FOSS's website walking you through some of those hands-on activities that are a part of that. So it's not going to feel quite like a FOSS training, which is all right. We will cover a lot of curriculum in a short period of time. I will be moving forward fairly quickly, but because this is a webinar, please do feel free to pause and look around and digest and take some notes as you move along. So yes, please do use that pause button and give yourself some time to kind of think things through. So if you're watching this, you are most likely being super affected by COVID-related school closures in fall 2020. So this project will look very different if it is implemented remotely. I will be giving you suggestions throughout on some things you can do to cater this for a remote or blended learning environment. It's actually very doable and very easily implementable even at home with students. So I'm hoping that some of the ideas are going to be super transferable for you, and I'm hoping that some of the slides and resources will be helpful for you as you plan for what some of that STEM learning can look like in the home space. My email address is linked at the very end of the presentation. So if you need help with figuring out how to create this in that remote learning space, please do reach out to me for additional support with this. I'd be happy to talk to you and support you in that way. Lesson 1. In this lesson, students will launch into the project where they are designing a nutritious and delicious meal for their first grade buddies. This lesson will begin by allowing students to define the problem and ask questions. Students will then construct an initial model of their snack and create a survey to collect data from the first graders. Session 1, what's for lunch? We have a problem. The way that we start this unit is by sharing with the fifth graders that we are having a problem with the first graders not eating their lunches. You can ask students why it's important to eat food and why it's kind of a big deal that the first graders are refusing to eat their lunches. And then we tell students that each team of fifth graders is going to actually design a snack for a class of first graders or a group of first graders. And once this mini meal is designed, they're actually going to construct the meal and serve it, hopefully making the first graders healthier and happier. So a driving question for this unit is, how can we create a nutritious and delicious snack for our first graders? So this driving question is super important. It's going to help anchor students' learning throughout the unit. In project-based learning, driving questions are super important because they help bring coherence to the unit. They help students answer that question of, well, why in the world am I learning this? So our driving question for this unit is focused around creating a nutritious and delicious snack for first graders. So if you are watching this as you're preparing to create instruction or adapt instruction for remote learning, one way you can actually spin this is instead of focusing on creating a snack for first graders, because that's probably not possible, and serving the snack is definitely not possible, you can focus on the family. How can we create a nutritious and delicious meal for our family? So the family focus is going to be just a really easy pivot for you and your students, and also just bringing in that home life connection that I think is going to be very valuable as you adapt this towards that remote learning space. So after we have the problem, I like to do this protocol called Notice, Wonder, Know. So it's a thinking routine where we have students think about things that they notice in the problem, things that they wonder about the problem, and then things that they know. So for fifth graders, I would have them actually write down one thing they notice, one thing they know, one thing they wonder, each on a Post-it. Now, if you're doing this remotely, Padlet or Jamboard are ways that you can actually have students literally make a Post-it digitally. So that's an avenue that you can choose to explore if you're doing this virtually or remotely. So after students have really started thinking about what they know about the problem of kiddos not eating their food, what they notice about the problem, well, what are things that are going to be important? What are some things that they wondered? What are some questions that they have about how they're going to be able to create a really awesome meal? Then we do this thing called the scientist circle. In this case, I'm calling it the food scientist circle. So the way that this is done in a traditional learning space is, I'm talking about in person, you gather students around in a circle. You have 3 charts up: notice, wonder, know. So what we notice, what we wonder, what we know. You ask one student to start by sharing something that they noticed about the problem. They can start by reading their Post-it. Once one student has shared, then you take their Post-it, you stick it on the notice chart, and then you ask if any other students have something similar that they noticed. You allow students to share and take their Post-its and post them up as they share with you. You continue adding to that chart. So you're kind of building and sense making together, but it's more of an initial process to get students really thinking about and kind of invested in that phenomenon that you're trying to get them excited about. So once students share their noticings, you move on to wonderings and then knowings. The idea is that each student is going to have a chance to share something with the class. It's really important that each student's voice be heard in this scientist circle. If that means that a student piggybacks off another student's idea and repeats it back, that's okay. If that means that a student shares a drawing that they made on their Post-it with the class to share on that notice, wonder, know board, then that's okay. It's just very important for each kid to be able to talk. It's important for each of them to have a voice that's heard in the classroom. And then it's also important for you to be connecting to that prior knowledge, the stuff they already know. And at this point, I wouldn't call it the stuff they think they know. I would call it just the things that you know that you can connect to this problem. And right now is really a space to validate those knowings, regardless of how correct or incorrect they are. Right now, you're creating a inclusive space that really appreciates their funds of knowledge that they've developed over the years based on their background. So I like to always end with, well, what else do we need to know before we can actually solve the problem? And that helps students sometimes think about more wonderings or more questions that are going to guide their thinking throughout the project. From what I've noticed in working with students is that they really struggle with asking questions. So it might be important for you to pause and model some questions, maybe even give them some words to start their questions with. So oftentimes questions start with the word why, sometimes with the word what, sometimes with the word how. So just reviewing what's a question, how can we start some questions is going to be helpful in helping them to articulate their questions and their thoughts. This can even be hard for high school kids. So really scaffold that questioning process. And I have a couple of handouts. Actually, they're more like informational letters to send to families and then also to your principal to talk about this project-based learning project. Um, this may look a little different in the remote learning space, but I have Google Docs linked through the curriculum unit and also in the Google Drive folder there for you, where you can actually um, use that and you can edit that to suit your needs. I think that this is a very community-based PBL unit, which would require you to really reach out to those people in your building that would be able to help you. So parent volunteers would be great, cafeteria folks would be great, and then having the support of your principal would be very important as well. Session 2, brainstorming the meal. Tell students that today we will start the process of planning the awesome meal for the first graders. Ask students to share what some of their favorite meals are. What are some things that they know are healthy? What are some things that are delicious? So this is where students are going to start thinking about the meal. They might think that potato chips are a perfect meal. That's okay for this at this point. We're going to dig much, much deeper and they're going to have a chance to really refine that meal based on new things that they learn. So again, we're having them think about what's delicious mean? What does healthy mean? What are some examples of snacks that are delicious? What are examples of snacks that are healthy? And then we have a space where students are going to be able to draw their initial model, brainstorm about the snack that they're going to create. So if they're making a meal for their family for remote learning, they can brainstorm a meal just off the top of their head of what they want to make. We also have a handout that goes with that. So the slide is there, but the handout is actually what they're writing on. So sorry if I didn't mention this earlier. We are currently on page 8 of our curriculum unit in case you're following along. And there's an opportunity for students to give each other some feedback on their initial ideas or brainstorm of that meal. So I think it's important before we ask students to give feedback to let them know what kind and unkind feedback looks like. I don't think unkind feedback is helpful. I don't think that unkind feedback is something that we should allow students to give each other. Um, and so it's important to let them practice what really good feedback looks like. So I would use this slide to just have them practice and maybe to model a little bit of either kind or unkind feedback, just to kind of role play and let them see what that looks like. Sometimes I'm surprised at how adults don't know what kind and unkind feedback looks like and why kind feedback is so much more impactful, and helpful. So this is just an opportunity to have them practice before you have them actually talking through and talking about things together and trying to help each other. So the general idea should be helpfulness and community. So if we're working with a team and giving them feedback, we're actually wanting to help them, but we're also respecting their ideas and their thinking. Session 3, Surveying Our Buddies, Part 1. So we're going to reconnect with the driving question. How can we create a nutritious and delicious snack for our first graders? Driving question is going to be the anchor of this unit, and I would come back to it over and over and over again just to remind students why we're doing the learning. So I like to give students checklists, especially in PBL. It's easy for things to get kind of chaotic and crazy and unproductive if students do not have checklists for the day. At the same time, you want to give students some freedom and space to personalize their learning. So the checklist for this session for that day would be, we're trying to create a survey for the first graders so we can figure out what kinds of foods do they like. Because if we make a meal that includes foods that they hate, they're not going to eat it, and therefore, we didn't actually achieve our goal. So we're going to try to find out two things. What do we want to ask the first graders? And then how do we want to ask them that? So the task for the teams is to make a short list of questions and then to figure out how we want to survey them. Is there going to be a online survey? Is there going to be a paper written survey? Is there going to be one person that goes over to that classroom and asks questions to that specific group of first graders? What are we thinking? How are we going to make our survey? If this is something that you are implementing remotely and students are making a meal for their family, same thing goes. What do they want to ask their family members? And then how are they going to collect that information? So we have students looking at each other's surveys and giving each other feedback. So important things for teams to consider. Are the questions easy to understand for the first graders? Will the survey give that team information that will actually be helpful when creating the snack, or is it kind of random? Are there any things that they can help them with? And then have the first graders' needs actually been considered in the survey? So we're just trying to have students work with each other to just think through, is this survey actually performing the function that it's intended to? And then you can create a space where they look at each other's surveys. Maybe one team had an idea that was really rock solid, and the rest of the class wants to actually pilfer that idea. That is totally welcome because we are building our understanding of things as a community. It's more about collaboration than it is about competition. So between sessions 3 and 4, we actually have students send out those surveys and bring in some data from the first graders. So it depends on you how you want to do that. If it's an online survey, that's something you can coordinate with that first grade teacher. If it's an in-person survey, then that would be something that you can also facilitate with the first grade teacher. And then we are collecting that data. And session 4 is just about making sense of the data. So there are some really close, strong Common Core math connections in this session. So here we're having students look at the responses that they received. If they received 5 responses, how can they organize that information by tallying or counting numbers to see what the data shows? There are a lot of different ways to do this. It's up to you how much freedom you want to give students. It's also up to you how much you want to model this, or if you want to let them kind of tinker with it and make mistakes and come to an understanding on their own. So it depends on you as a teacher, how you would like to have them engage with that data initially. If they're stuck, maybe they can look at each question on each survey one at a time. So looking at each question one at a time, seeing how the first graders responded, and then moving on to a next question. So start by looking at a question, how many students chose each response, and then moving on. So here's a video on creating a line plot. Line plots are something that fifth graders are supposed to learn how to create using different data points. So this is something that you can show them and then let them have a chance to try to show their data in that way. I think it's also great to be open to letting them display the information that they collected in a different way, maybe a pie chart, bar graph. If those are things that you need to provide them with more information on, there's a lot of videos online talking about the basics of pie charts, bar graphs, things like that. Um, I just chose to include line plots in here because that's a fifth grade Common Core mathematics focus for them to be able to do that. So this is a time for you to give them some space to display their data visually. It's a really important skill for students to be able to take some pieces of information and show them in a way other than numbers. So something that is a little bit more easy for the brain to process. So depending on how comfortable you feel, I'd give them some degree of freedom on how they wanted to show their data displays. And then there's an idea of having a data gallery walk where students go around and look at the data that was collected by different teams and use that data to inform themselves. So what do the first graders seem to actually like? Is there a pattern that we notice in the data that we collected together as a class? How's this going to affect our development of the perfect snack for these first graders? So I wanted to point out that in our units, after each lesson, there's an NGSS alignment guide. So if you take a look at page 11, you'll see that there's a guide that shows you how the lesson aligns with the performance expectations, the disciplinary core ideas, science and engineering practices, and the cross-cutting concepts for those NGSS standards from that bundle. So just wanted to call your attention for you to take a look and see where that alignment is, just to help inform your practice and just to help you see that you actually are teaching pretty strongly aligned to next generation science standards through this STEM storyline. In this lesson, students are going to explore the chemical and nutritional properties of different beverages, so different things to drink. They're going to investigate by creating different solutions that are composed of different substances. So they're going to be mixing powders. So this is where the FOSS investigation is going to come in. They're going to deepen their understanding of what to drink by researching the nutritional value of different beverages. They're going to finish this lesson by reflecting on what type of a drink they might want to include with their snack for their first graders. Session 1, mystery drinks. So this is a session that we've added in just to tie in some relevance to daily lives of students before we jump into the FOSS investigation stations. So in this specific lesson, pretty much we present students with some mystery drinks. So 4 or 5 different edible drinks that students are going to try and think about. So there's some materials that you would need to gather before you're able to actually implement this session. And this is also a session that can be done pretty easily in the home space by having students investigate different liquids around the house. So in this session, students are going to start with one liquid, make visual observations about that liquid, taste it by pouring the liquid or a little bit into their spoon and tasting, talk with their team about what they taste, and then record observations about what they taste. They're also going to make a hypothesis about what each drink is. So they pretty much move through each mystery drink and talk through it with their team. Then we have students make sense of the investigation and to think about what each drink was. So they're actually working together to figure out what was each drink. So here is where you would input what the actual drinks were. You don't need to have 6. You could have from 1 to 4 would be fine, 1 to 4 different types of drinks. And then you can insert the actual identity of those different mystery drinks. This is also something that you can have students do at home. You might have an adult actually help with putting a couple of mystery drinks in different cups and having students actually taste and try to figure out what they are. So we're trying to pretty much call attention to the fact that different substances have different characteristics. One way we can tell that is because they look different. Another way that they have different characteristics is that they taste different. Here is a graph showing the sugar content of different common drinks. Now that I look at this, some of these are not very common in the US, but some of them are. If you find a chart that better matches the drinks that you chose, then please do replace this. We're just having students think about the sugar content of the beverages and maybe connecting it to how much did they like each mystery drink and how does that relate with the sugar content of that. Generally, kids tend to like the drinks that are more sugary and have a higher sugar content. Not always the case, but sometimes. And then here's another example of milk and the different sugar and protein contents of different types of plant-based or dairy milk. Sessions 2 and 3, investigation stations. So here is where we have incorporated some of the FOSS investigations that are from the Mixtures and Solutions kit. Instead of doing these investigations as separate activities, how FOSS suggests, we suggest that you set up stations for students so they're able to actually work in small groups and investigate different concepts while preparing for what type of a drink they're going to include as a part of their snack. So these station signs that are included next can actually be used to direct students. Let students know that our focus of these stations is to develop an understanding of what makes up drinks so we can make an informed decision about the drink that we choose to offer our first graders. There's a thinking template that's included to help students jot down their thoughts as they move from station to station. This would also be something that lasted probably 2 sessions. There's plenty of stations and you might want to give them some time on each. So I would split this up in 2 days. For remote learning, this is something that you could pre-record as a teacher and share that video with students. There's also a way you could actually pass out some of the materials to your students and have different groups of students investigate a different station and then come back together as a class to share information. So these are just going to be station signs for you to check out. I'm going to possibly talk through some of them for you. So this is a station based on one of the FOSS investigations. Pretty much students are just dissolving salt in water and seeing how much of the salt is able to dissolve in the water. Now, one of the NGSS standards focuses around how when you have a combination of 2 substances, when you combine them, then the resulting substance has a mass that is equal to those 2 substances' original mass combined. So that's why we suggest that you weigh the water in advance to see how much you started with, weigh some salt in advance to see how much you have in the scoop, and then combine them, and then see what happens at the end after the salt and the water are combined. What students should find is that the amount of the salt in the water from the beginning and then the combined amount of the salt and the water at the end should be the same. So that's the idea for this weighing of the mixture after and then the different parts of the mixture before they're actually mixed up. So you're going to see that as kind of like a recurring step in the stations. If you think that the weighing is a little bit too much and you want to just have them make observations that are not so focused on the math and the computation, that's all right as well. So we just included that in there to provide a stronger alignment with the next generation science standards. So same thing as the previous station, but here we're dissolving citric acid instead of salt. And then here we have a soft drink recipe that they're dissolving. And this also has something to do with taste. So we're having them taste what's the perfect amount of soft drink solution to actually add. And then here is just a fun station where they're going to be mixing different substances into water. So here, this materials for this station are not actually provided. I would use things such as honey, peanut butter, and maybe oil possibly one other substance that's easier to mix, like juice or milk. And pretty much they have 4 different substances. They mix it into water, and then they see how well the different substances actually mix. Again, we are only really investigating properties of matter. So we're trying to see what's the mixability of these different substances. Some are easier to mix and some are more difficult. And then this is just a quick look at the different stations and the thinking template that accompanies them. And so just having students calculate, there's an area for calculations, and then there's a simple area for noticings, wonderings, and knowings. Graphing their findings. So here's where we're actually having students wrap up their data collection and bring the whole group together. We present students with a graph. We ask one team to share their data and for station 1, and we actually graph students' quantities up. So if you are having each team actually do each station, ask one team to volunteer and use that data that they collected to graph students' quantities up. I have a slide as an example in the next slide, so I'll show you what that could look like. And then you can ask another team to share their data and model the process again. Allow teams to work in groups to graph their other sets of data. So this is also something that's relating with the idea of computational thinking and creating graphs. So we have some mathematical connections we're making here. What we want students to see, actually I'm going to show you the graph on the next page to show you what we kind of want students to see. So we would like students to see, this is an example of one team's information graph. So if you can see this bar on the very left side, it is the blue bar. 30 grams of water was mixed into about 5 grams of powder, which resulted in about, if you look across, follow across that yellow bar all the way to the left side of our graph, it's about 35 grams of solution. So what we're trying to get them to see is a trend that the 2 substances that you were combining, the mass of those substances adds together to make the mass of your final solution. And this is directly an NGSS standard showing that the amount of mass in a solution is the same as the mass of the different components of that solution before they were mixed up. So here's an example for you. You can use students' data and graph it for them a couple times before expecting them to do that on their own, depending on how your students feel with this. So we want students to look at the bars and make some observations. Are there any patterns they notice about before the mixing and after the mixing? Hopefully they'll see that when you have a solution that you're creating, the different parts of your solution, the mass of those combined pretty much gives you the mass of your solution at the end. So we're hoping for them to see that pattern and consistency. It's okay if they don't fully get it, but we're hoping that they'll make some observations about that. Session 4, or possibly a couple more, which drink to choose. So for this session, we're going to ask students to think about their initial design for a perfect snack. If they could include a drink with that, what would it be and why? Ask students to talk in their group and remind themselves about what their choices might be for that. Tell students that this week they're going to be breaking up into expert groups. They're going to research different drinks, and then they're going to advise the class whether or not they think that the drink they chose is a good choice for the first graders. So the idea is we're going to split them up into expert groups. They're going to research about that drink, and then they're going to report back to the class. So the idea is not for them to try to convince the class to choose their drink. It's just they're trying to contribute to the community, the class community, and they're trying to really figure out if the drink they were assigned is a good one or not. So again, we're trying not to build competition. We're trying to build collaboration and community here. So tell students that they're actually going to be breaking up into expert groups based on different drinks that they're going to be researching. So I would split students up into groups of 3 to 4, assign them with a specific drink to research. Some options include soda, fresh juice, milk, soy milk, Gatorade, juice from concentrate. You can add some other ones in there if they're class favorites. Students can use this research and thinking guide, which will also serve as a formative assessment for you to see what they're accomplishing individually. So when I have students working in groups, I like to have them have something that they're doing individually. It's really hard, it gets really murky trying to figure out what each student gets and doesn't get when you're not collecting that individual data. So I like to have this research and thinking guide on the side to see how each student is actually doing and reaching their goals or not. So now that students know what drinks they're going to be researching, here are some questions that are going to help guide their thinking and guide their researching. What is their drink made of? How is it made? Is it nutritious? Why or why not? And would you recommend any classmates to include this drink as a part of their snack? Why or why not? So the why or why not part is really important, and I'm hoping that's going to help them actually dig deeper. You can let them loose on the internet within safe parameters, or you can provide them with some information. I think at 5th grade, they might be pretty able to locate some videos or other information that would be helpful, also some articles. It would be important to have a conversation about where they're getting their information from. So if you're trying to research Coca-Cola, I think Coca-Cola's website is going to be the best place to get information because they are actually trying to sell you their products and they're not going to be completely honest with you about what's actually in it. So talk about credibility of resources would be a great point in this research project, this mini research project. So on the back of their thinking guide, there's a place where each student can create a model showing the different parts of their drink. This model should be a picture showing some of the unseen particles that the drink is made of. So if we're talking about orange juice, there's going to be some particles in there that you don't really see that the drink is made of. Different tiny chunks of oranges perhaps. The water liquid that's included in an orange when you juice it perhaps. If they're looking at something like Kool-Aid, there's going to be also some water and some tiny Kool-Aid particles that are probably made of sugar and some artificial coloring and stuff like that. So the point is for students to actually break down what their drink is composed of. In doing so, we're actually really well addressing one of our NGSS standards that talk about students understanding how sometimes materials are made up of particles that we cannot even see. So we're having them think, what is their drink made of? To tell the class if they would recommend this drink or not, and then give at least 3 reasons why they decided that. So they can turn their individual models into a team poster. If a slideshow is easier, that works as well, that they can actually share with the class. And then we have them present their recommendations to the class. I am thinking that if your students have shown some success in working in teams virtually, this could be a fun thing they actually work on together in the virtual space and then share out with the rest of the class as a slide. And then students will present their recommendation to the class. So would you recommend your research drink as a part of a healthy meal? Yes or no? And again, we're trying to show students that their voices and their learning has really applicable value for people around them. Session 5, revising the model. So these are probably my favorite parts of these storylines is the parts where they go back to their model and they create revisions. I think it's a great way to see how they're growing as learners and how their understanding is deepening. It's a very important sense-making routine that we've embedded throughout our units. So here, students are going to meet with their group and revisit their model for a perfect snack. Did you learn something from your classmates that made you want to change your mind? Is your drink healthy? Why or why not? Do you want to switch to a different drink? If so, why and what might be a better choice? If not, why is your drink a good choice? We're having them reflect on their model and make revisions. So that's one of the great parts of teaching science and engineering practices. Things are constantly changing and it's okay to be changing your ideas about how you want to do things based on new information that you learn. So one of my favorite parts are these sense-making parts of the unit. So we have an NGSS guide on page 18 for you to look at just to see how and where this activity that we just did aligns with different NGSS standards and different strands in NGSS. So go ahead and take a look at that just to see where those alignments are. Lesson 3 is called Mixing It Up. This is where things start to get a little more interesting in my opinion. So in this lesson, students are going to explore the various physical and nutritional properties of different foods and continue to develop their model of the perfect snack for their first grade buddies. Or if they're working on creating a meal for their family, they're going to investigate the properties of different foods that they can use to make that meal. So session 1, characteristics of foods. It's similar to the mystery drinks lesson that we did, session that we did with the previous lesson. So in this session, we're going to have the teacher actually gather some foods for exploration, try to make sure that the foods that you're picking are actually allergy friendly. I've included a list of foods for you to explore that are generally allergy friendly. This might be a place for the cafeteria staff to actually help you out. It could be a activity that you do at the cafeteria to, make things a little bit fun and interesting. This is also something that you can facilitate with students at home where you have them actually look at a couple different foods and scavenge for a couple different foods in their home and investigate the different properties of these foods. So we're trying to get an understanding of that so we can craft the best possible meal or snack for our first graders. So here's a career connection that's going to be important to highlight for students. We want to show them that the work that they're doing in class is actually very similar to the work that's done in the real world by really, really cool STEM and other professionals. So we can tell students that in the following lessons, they're actually going to act as food scientists. They're going to study the properties of foods, understand what they're made of, and use this information to refine their own snack. So driving question is super important when we are trying to have students tie together their understanding and develop a deeper understanding of the material. It also provides the why behind the unit. Just why are we doing this learning? What is it going to make a difference and how? So students have a pretty simple food scientist log, which I'm going to show you in a second, where they write down their observations about different foods that they're testing. Here's what it looks like. So which food did they test? What does it look like? How does it feel? And then how does it taste? So I can imagine that in COVID times, this is something that we're going to have students do at home. And honestly, when schools do open up, I'm not sure when this is going to be a possible thing to do. So this is going to be something that we are really leveraging the home environment in order to achieve. And this is also directly linked to one of our NGSS standards for physical science, which has students look at the properties of materials. So we're talking about what color, shapes, textures, how they feel, and then taste. Those are all properties of different materials. So it's really important to have students reconnect with their projects so they don't forget the reason behind all of this investigating. So have students revisit the data that they collected. What types of foods do the first graders want? Do we have any thoughts or ideas, excuse me, on how to make this snack better? For instance, did they like crunchy fruits? Did they like soft fruits? Did they like sweet things or salty things or sour things? What were some of the other textures that they liked or did not like? So give a chance for students to reconnect with the project, reconnect with the data that they've collected earlier. Session 2, nutritious or not. So here students are going to read an article on Nutella and talk about different food groups and learn about how to balance different food groups to make a nutritious meal. So we start by having students think about examples of healthy food. They may have some preconceptions that are incorrect, and that's okay. So here we have another career connection to the profession of a dietitian. A dietitian essentially helps people stay healthy by eating certain foods and staying away from other foods. So they're trying to do this for their first graders, trying to create a meal or a snack that's actually going to keep them healthy versus not. We have students read the article building your plate with their team. I have a snapshot of the article in the next slide. So what are areas of the healthy eating plate that their snack actually incorporates? And what areas of the plate is the snack not actually covering? Ask students to try to include at least 3 groups into their snack. So in order to access Newsela articles, you actually need to create an account and log in. So if you click our link to this article through the STEM Storyline actual unit guide, you're going to get to the login screen. So I put this snapshot in here just to help you locate it once you're in. It should be pretty easy for you to find it once you get in there. And now we're having students reconnect with their project. So what are some things that they might add in order to make their snack more balanced? What are some things that they might take out to make it healthier? So we're having students, again, optimize, go back to that draft. What have you learned? How can you change your model? How can you improve it? So this model is a pretty living formative assessment to see how students are actually understanding the material. Session 3, food groups research. So this session is similar to the session in the previous lesson where they researched a specific drink. So here we're going to have students research a specific food group and talk about how this food group is important in providing nutrition that's important to the human body. So have students pick a food group that interests them most. If you feel like you need to do a little bit of delegation there to make sure that each food group has people assigned to it, go ahead and do that. And I'm not sure why I wrote here not to join the water group. I feel like water is really important, and maybe that is a group that some students can actually tackle. So it might actually be harder than people think it is. So I'm going to scratch that on not joining the water group. I think water is actually super important, very important to understand why we need to drink water every day. So this is the healthy eating plate that actually was created by people at Harvard Medical School. So it's different than the plate that has been pushed out by the US Department of Health. In this one, instead of milk, we have water. So there's some research that's shown the negative impact of milk in the diet, which is why there's that little switch there, just in case you were wondering why this looks a little different. So here's a checklist of things and kind of like a sequence of what we're expecting students to do for the food groups research. Their drinks research was a little bit of a practice session preparing for this one. Again, we're having students reconnect with their project. What are some changes they can make after the information that they've learned? And now wanted to just direct your attention to the NGSS guide on page 27. Please take a look and see where different elements of this lesson actually align really well with the NGSS standards. This is a super interesting lesson. I personally feel it's interesting. It's called Food in Our Environment, and it seems like it's a little bit of a detour, but pretty much in this lesson, students study the phenomenon of climate change and how the Pacific Northwest is specifically being affected by it. And then students research how the foods we eat actually can impact the environment. They apply their learning to refine their snack to be more environmentally sustainable. So while some people may see that this is a bit of a detour and a stretch, I think it's actually really important to be conscious of the way that our food choices actually impact our environment. In 5th grade, I feel like students are old enough to start thinking about some of that. If you've been following just sustainability education for the past 10 or so years, there's been a real focus on how our daily lifestyle changes can actually positively impact the environment. So based on your comfort level, I hope you will incorporate some of this lesson into your learning sequence for this unit. Session 1, what is climate change? So, important question, does what we eat make a difference on the environment? Students may have some preconceptions about this, which is awesome. we have a series of videos and other pieces of information that are going to help them just think through this question. So we have this essential question that we're working on in this lesson. I think when talking about things like climate change, I think it's important not to, especially at this grade level, not to push ideas onto students, but to actually present them with interesting pieces of data that help them make sense of this phenomenon on their own. Especially if you think about some of the family perceptions about this topic, it's kind of in a somewhat of a safer place to provide students with actual hardcore evidence and data that helps them come to some conclusions about climate change on their own versus the other way around, where we're presenting the view and then supporting with evidence. So here are some nuggets of information that may help you to talk to these fifth graders about climate change and the effect that their eating can have on the environment. So here's a quick video on climate change according to a kid. I like it because it's simple and not complicated. At fifth grade, I think that we need to keep it simple and focus on some of the human impacts to the environment that are really tangible and visible. So here's a video, you can check it out and decide to use it. Here is a really interesting book called My Wounded Island by Jacques Basquet. And it is really fascinating. It talks about, or it follows the narration of a young girl named Imarvaluk, whose island is actually being affected by a lot of changes. And it's an interesting way to show students of the actual menacing nature of climate change and how it's been affecting a lot of communities already around the world. So I found it to be super interesting. I read it to my son, who's a kindergartner, and he was super intrigued by it, very concerned by it, also intrigued by it. So in this, climate change is personified as a creature that has possessed the ocean, and this ocean is taking over the island. It is engulfing the island. So I think it's a interesting book to talk to your fifth graders about some of the actual impacts of climate change. It's a picture book story style, so it's not going to be a difficult read, but I think it's a fascinating one. So we've included it in our kit for you to actually have with you. So here we have an article about climate change and the Pacific Northwest. So in your, you can have students work in teams to actually read a chunk and then report back to the class on how the Pacific Northwest is being affected by climate change. Session 2, does what we eat make a difference for the Earth? So here's an interesting video, and it talks about if what we eat can impact the environment. So it follows a group of researchers in California who actually researched that question. I think it was an interesting video for me to watch, actually. I would check it out if I were you and see if it's something you'd want to use with your students. So as you may know, there's a such thing called a carbon footprint, and pretty much this carbon footprint shows the impact that our lifestyle has on contributing to carbon emissions that are released into the atmosphere. So there's there are a lot of surveys out there that help you calculate the carbon footprint that you have based on your lifestyle. So it could be depending on where you live, what type of a house you live in, or if you live in an apartment building, your energy usage, how much you travel, what you eat is a part of it. So this specific survey that I've found, it actually focuses on food choices and the impact on the environment based on food choices. So there's a way that students can access that drop-down menu, pick some of the ingredients that are in their model of their snack, and to actually, they can actually calculate the amount of carbon that would be released into the atmosphere based on the use of that specific ingredient in their snack. So I think it's a really tangible way to think about the sustainability of the snack that they've chosen. And it might just be fun for them to experiment and check out on their own, the differences between different ingredients and the impact on the environment. So we have students share out what they found from that survey. I think they might have fun sharing the different findings based on different foods that they incorporated into their model. So in the next two slides, you can see some graphs that show a pretty visual representation of the release of carbon dioxide into the atmosphere as a result of different foods being produced. So there's one here, and then there's another graph. I've also linked to the fact sheet that I got this information from. It's in the notes of each slide. So if you were curious and wanted to dig deeper and see where this data came from, you can go ahead and click that link and check this out. So here's this bar graph. Same information, well, similar information, just a little bit different represented. And then very important, have students reconnect with their project. How sustainable are their ingredients? Do they think there's some changes they can make, little swaps here and there, to have their food have less of an impact on the environment? So trying to create something that's sustainable. Again, this may seem like a little bit of a detour, but I think it's valuable to have them just reflect on this. It's their choice of whether or not they actually want to make a change. Lesson 5, and snack is served. So in this lesson, students refine their snack recipes using some computational thinking and all the information and data that they've collected throughout the unit. Their models are finalized as they get ready for the STEM snack fair. Students finally prepare and share snacks with their first grade buddies. So this lesson will look different in the remote space in the sense that students will be actually creating their recipes and refining them to be used to create a meal for their family. Students' recipes can actually also be shared with the class, so students can develop together as a class a recipe book of these super awesome refined recipes for other classmates to test out with their families. So there's are ways that this can be totally modified to work in the remote learning space. Session 1, writing the ratio recipes. So tell students that before we make our snacks, we have to figure out the different parts of the snack and how they're going to work together to create the healthy and delicious snack. Ask students if they've ever used a recipe. What is a recipe? Was it helpful? Why was it helpful? Why was it not helpful? Why would it be helpful for us to create a recipe for our snack? Have students work with their teams to brainstorm the ingredients that they plan on using. I'm going to show you a template in a second that they can use. So we're going to incorporate some mathematics into this by having them think about fractions and what fraction of certain ingredients will they be using to create their snack as a whole. So how much of each ingredient will your snack have? Have students work in their teams to make a recipe for their snack using the template, which I will show you in a second. How much of each ingredient do they plan on using? And then what fraction of the main snack would each ingredient be? So they're going to have a chance to try to figure out how each fraction of each ingredient is going to add up to that whole snack. So here are the recipe planning kind of like templates that I've attached here. So students can use fractions to actually label to describe the amounts of each ingredient that they've chosen for their snack. And then ideally, all their fractions will add up to the number 1. So add up all the fractions from your recipe above. That's what they're going to do after they've created that pie chart. Do your fractions all add up to 1? If not, what can you adjust to make them add up to 1? So there's going to be some tinkering with math ideas. It depends on kind of what time of the year you're introducing this unit, and also how much mini lessoning you'd like to do to get students actually adding up the fractions correctly. What time of the year is this? Is this appropriate? This could be just a way for them to tinker with this idea of fraction before you actually explicitly work on them learning it, or this could be a really authentic opportunity to talk about fractions and the way that we add different amounts of fractions. I think that the visual piece should make it a little bit easier for them to grasp. However, fractions, as you know, are a very difficult concept to understand. So perhaps the actual real-life connection would make this a little bit more fun and interesting to do. I'm really curious for your feedback on if you try this out, on whether it worked or not, and I'm very open to you sharing that with me so I can make some changes in this unit. Session 2, refining the recipes. So here students are going to work on creating a recipe. So they're going to decide how much of each ingredient they're going to be using. So they can use their fraction pie chart that they created earlier to help them decide how much of each ingredient they're going to use. It is up to you how technical you'd like them to get and how closely you want them to actually match the fractions that they had originally planned. And since they're going to be sharing their snack with the first graders, it's great if they're able to actually create their recipe using some larger quantities so that each team can make snacks, can make a snack that's going to be enough for maybe 10 first graders. So depending on how you're planning on having the potluck style share at the end, um, have them make a larger amount versus a very little amount, just so there's going to be enough for everybody. If they're doing this remotely and will be making the recipe for home, then you might want to focus on creating something for 4 or 5 people. So we're making the connection with the career of a master chef who is a cook who prepares recipes and food for people to eat at restaurants. Master chefs usually come up with the perfect recipe by coming up with the right combination of ingredients in the right amounts. They also come up with cool techniques to help their food taste especially amazing and be super delicious and super fun to eat. So here's a template that you can use to have them actually create their recipe. So they have a column for ingredients, a column for the fraction of their original recipe, of their ratios that they had decided on. What type of measurement are we using? So we're introducing the idea of units of measurement. In the US, we use the non-standard units of measurement, such as cups, teaspoons, and tablespoons. It's up to you if you want to switch to metric. It might be a little confusing for the students, but in science, we're actually supposed to use standardized units, which is what I was usually using when I was teaching science in high school. But for the 5th grade kiddos, this might be more familiar. How much of each how much of this measurement, how much of this unit are we going to use? So they're just brainstorming and creating a plan to actually create their recipe. There is a conversion table in case they needed help. It might be helpful if they look at the biggest quantity of whatever ingredient they have in their snack and start with just 1 cup or a couple of cups of that ingredient and then kind of work backwards to fill in the amounts that they want for the other kind of like supporting role ingredients for their snack. So students are going to be doing this at home. I think it would be so cool for them to be able to write recipes and then share the recipe with the rest of the class to enjoy. So in a second, I'm going to show you the next part of this lesson. But if you're actually going to have them do this at home, I would recommend that you actually have them write out the recipe. So they have their amounts of ingredients, and I would extend this activity since it's not something they're making themselves and sharing with the first graders, since it's something they're going to be sharing with the class so that the class can replicate that in their own home environment. You need to have instructions on how to actually create the meal. So in that case, I would probably extend this to more of an ELA type assignment where students list their ingredients and then list detailed step-by-step procedure on how to actually create that recipe. They probably need parent help in order to figure out how to cook it in those terms and such. Parent or family member help. So just an idea in case you're doing this during remote learning. Session 3, model of the amazing snack. So this is more created if you're actually going to be having a STEM snack fair for the first graders. We would want the first graders to actually see all the cool stuff that's inside the snack that the 5th graders plan for them. So the idea of the model of this amazing snack is a poster with just an image of the snack with all the different ingredients labeled, so students know what they're eating. And so your students can show off like all the amazing stuff they've done and picked for this really delicious and super healthy snack that they've created, that they've crafted for the first grader. So here's a little nugget about why we're creating this model. We have a career connection to marketing manager. So marketing manager develops and oversees efforts to market and advertise a product or products. So in this case, we are marketing the awesomeness of our snack so that first graders don't take us for granted. So they know how hard we've worked, how much we've researched, and how much thought was actually put into the creation of the snack for them. Here are some things that I would ask my fifth graders to include in their model. And finally, to have a gallery walk. So this is an internal gallery walk with your class so that they can see each other's models. So I hope by this time they're starting to get excited about the amazing work that they've done and how awesome the STEM fair is going to be. Session 4, get cooking. In this session, you're going to want to recruit some volunteers to help you out. This is going to be the session where students actually create their snack. So coordinate with the first grade teacher to make sure that there's a good time that their first graders are going to be able to come by and check out the snacks that the fifth graders have created for them. And so we would want the fifth graders to create this snack a few hours before the STEM snack fair. Make sure you have access to a refrigerator if the snack is something that's perishable. And then again, recruiting help from volunteers will be important. You can also ask volunteers to bring in things such as cutting boards. I would, if possible, do some of this creating in the cafeteria if the cafeteria staff is able to host you for an hour so students can make their snacks. I can just imagine it being way less messy that way. And that way they'll also have access to certain things like big bowls and knives and such. So also knives, we would not want kiddos using the knives. We probably would just want the volunteers and the adults that are there to be able to use those. So this would require some coordination on your part. If you're doing this remotely, then this part of the lesson probably won't happen together as a class. This is something that the students would do with their home, with their family in their home. Here are some thoughts for cooking this snack that you can look through. And then session 5, the STEM snack fair. Snacks are served. The exciting time is here, and be sure to really hype up this event and celebrate your students' successes. I had some ideas for ways that you could facilitate this STEM snack fair. One idea is a snack gallery walk. You can check out each description of these different ideas. If you're implementing this during remote instruction, it's going to look very different. Probably will just be students creating this meal or the snack for their family at home. Chefs and their tables, idea number 2. And then idea number 3, snack delivery. If you're not actually able to have some type of a STEM fair, snacks can be created and delivered to the first graders. Please take a look at the NGSS guide on page 34 for some information on how this lesson aligns well to the NGSS standards bundle. Congratulations to you and your students for doing a whole lot of really amazing investigating and researching and sense making to figure out how to create the most delicious and most nutritious snack ever possible for the first graders in your building. So really celebrate the success of you and your students. And I hope the first graders gave a lot of really positive and amazing feedback to your students. So this would be just the end of our STEM storyline, where we can really see the hard work of our students coming to fruition, and just to be very, very proud of them. So congratulations, and congratulations that you made it through my webinar. I have a couple more slides left with some tidbits of information, so hang out for a few more minutes and check that out. And thanks again for joining me. I promised that I would share some information with you about the FOSS-Web materials that you could access online, just if you wanted to try to find some more support materials for implementing the FOSS chunk of this storyline. So you have to access fossweb.com. It's going to take you to this page right here, and you actually have to create a account using your work email. So you would have to register, and here's the access code that you would enter, and it would give you access to a whole bunch of online FOSS materials. And then you have to find the mixtures and solutions kit for 5th grade. Once you get into that, it's going to look something like this. This is the structures of life, so this is a 3rd grade unit, but the one you're going to be looking for should say mixtures and solutions. And here are just a bunch of materials that you will be able to access. And this should be helpful if you're trying to look at the way that the FOSS investigations are actually done. I would de-emphasize the importance of sticking with the FOSS guide and ask you to kind of focus more on the STEM storyline and some of the different routines that are in there that get students thinking a little bit more deeply about science ideas. However, it is sometimes helpful to actually have some support when it comes to the actual hands-on materials. So that's there for you. Thank you so much for joining me in this webinar. I hope that it was helpful to you. I hope that you'll be able to use some of this in some way, shape, or form soon. If you are teaching this during COVID times, then I hope you'll be able to translate some of it into a meaningful unit that could be done with students in the home space. Cooking is a super relevant phenomenon that can be, that's something that happens daily in a household, and or in most households, and is something that you should be able to connect with to make that connection between home and some really important STEM concepts. So my email is right here in case you'd like to reach out. Please reach out to me and share student work samples. I love to see those. I'd love to be able to share the amazing work of you and your students with people across the state. So please do share that. Please get in touch with me if I can be of more help. Please let me know if there's things that you see that need to be changed. I'm very open to feedback. Again, thank you so much for joining. I hope that this was helpful. Take care, and hopefully I will see you later sometime.